Bismillahirrahmanirrahim. Assalamu alaikum students. I'm Nadeem Khan from GK College again. Today we are discussing the class 11 chapter number 2 atomic structure, and topic is properties of cathode rays. It can also be the characteristics of cathode rays. Now we are going to discuss the few properties of cathode rays. These were actually demonstrated by the different scientists, just like I had Roth, J.J. Thomson, Peary. So now we are going to discuss it number by number. Actually, cathode rays were some rays originating from cathode and they were traveling towards anode. An electric field was applied here, perpendicular to this. One was negatively charged, other was positively charged. When they applied an electric field perpendicular to the path of the propagation of the cathode rays, they observed that cathode rays, they bend towards positive plate. When they bend towards the positive plate, indicating that they are itself negatively charged particles. So we know cathode rays are electrons, they carry negative charge. So in presence of an externally applied electric field, they bend towards positive plate, and the bending towards positive plate indicate they are itself negatively charged particles. So they carry negative charge. This is one of the property of cathode rays. They are negatively charged. And second property, an opaque object. Actually, opaque object was the cross used by the all Christians have a cross, just like the locket. They wear it, and that cross was actually placed by the J.J. Thomson and the path of the cathode rays. For example, this is the cross. Actually, this was an opaque object. Opaque object is an object through which light cannot pass. So when they place an opaque object in the path of the discharge tube cathode rays, so it casts a shadow here. For example, if this is a screen, it casts a sharp shadow just like this. If this is the shadow of this opaque object, which was actually the cross of which is the symbol of Christianity. This was used by the J.J. Thomson. So it casts a shadow right in front of the object. So this indicates that these cathode rays move in a straight line, because this object casts a shadow right in front of that object where it was placed. So this means that cathode rays move in a straight line. Similarly, in the third experiment, parents placed a very small pen wheel. Pen wheel means very small wheel, which has a very small mass, that was placed in the path of, let's say this is a small axle, and it's a small wheel, pen wheel. It was placed in the path of the propagating cathode rays. This was very small, very pen wheel, very small wheel. When cathode rays are allowed to strike over this small pen wheel, it causes a slow rotation in this small wheel. So this rotation indicates that cathode rays carry some mass m, and they also have some velocity or kinetic energy, and product of mass and velocity is called momentum. This indicates that cathode rays has some momentum. They are material particles, they have some mass, they have some kinetic energy with which they are moving, and this actually was the main reason for the rotation of the small wheel by the striking of cathode rays. Similarly, another property was that when an object was placed in the path of the cathode rays, let's say they placed a plate here. When cathode rays were allowed to strike over this plate, it was heat up. It was heat it up. This means cathode rays can heat something, for example, just like the sunlight when falls upon any metal made utensil, that utensil becomes hot. So cathode rays have the same property. They can heat up any object which is placed in front of its path. So this is one of property of the cathode rays. Similarly, when an magnetic field was applied, not electric field, magnetic field was applied. Magnetic field, has a north and south poles. When this magnetic field was applied, the cathode rays move in a curved path. They traced a curved path. Actually, this indicates that uh, any magnetic field can move any particle which has some charge in a curved path. It compels any particle in a curve. So the deflection of the cathode rays indicate an presence of an externally applied magnetic field, indicate that these are charged particles. If they were neutral, they would have passed straight. So the deflection or the curvature of the path of the cathode rays and presence of externally applied magnetic field indicates that these are charged particles. They carry some charge, that's why they are deflected by the magnetic field. Similarly, the last observation or property of the cathode rays is that if we put or fill a gas inside the discharge tube, these cathode rays, which are originating from cathode, they strike the molecules of the cathode of the gas molecules and knock out one or more electrons from the gas molecules. When the one or more electrons are knocked out, this causes the ionization of the gas. And actually this is the origin of the cathode rays. Cathode rays are produced by the ionization of the gas or air, whatever it is present inside the tube. So it ionizes the gas or air which is present inside the discharge tube, but not at a very high pressure, but at low pressure. So cathode rays are produced by this. Some cathode rays are also ejected by the metal plate, but most of the cathode rays are formed. Cathode rays are actually electrons. Electrons are formed by the ionization of the gas. Gas consists of molecules. Molecules consist of atoms. Atoms have electrons, and these electrons are now knocked out. They are and the gas becomes ionized. So they can ionize the gas. Thank you. This was something about the properties of the cathode rays. And if you have any question or any query, you can call me. You can ask through the WhatsApp on whatever it is. Thank you all. Thank you. I thank you.